In Lesson 12.2, you will find the probability of independent and dependent events. We're going to start out with some vocabulary. The first word is compound event. Compounding event consists of two or more simple events. Independent events is where the outcome of one event does not affect the other, such as choosing a number tile and spinning a spinner. Probability of independent events can be found by multiplying the probabilities of the two events together, such as the probability of A and B happening is the probability of A multiplied by the probability of B. For example, one letter tile is selected and the spinner is spun. What is the probability that both will be a vowel? Well, the probability of choosing a vowel from the number tiles is 2 out of 7 possible. Since there are 7 tiles and 2 of them are vowels, it would be 2/7 multiplied by the probability of getting a vowel on the spinner, which is 2 out of 6. 2/7 times 2/6 is found by multiplying the numerators and then the denominators. So 4 over 42. And then that fraction can be simplified by dividing both the numerator and denominator by 2. So 2/21 is the probability of getting a vowel on the tiles and the spinner. Probability can be written as a fraction like that, or it can be written as a decimal by doing 2 divided by 21. Or as a percent by moving the decimal 2 places to the right. It's about 9.5%. Now the probability that both letters are A's, well, there's only one A out of the 7 tiles, so 1/7 times 1 out of 6 on the spinner, that's 1/42. As a decimal, it would be 1 divided by 42, which is this. And then as a percent, you could move the decimal over 2 places. It's about 2.4%. Now, dependent events is where the outcome of one event affects the outcome of another event. The probability of dependent events is found by multiplying the probability of the first event by the probability of the second event after the first one already happened. So the probability of A times the probability of B after A already happened. For example, there are 4 oranges, 7 bananas, and 5 apples in a fruit basket. Megan selects a piece of fruit at random, and then Terrence selects a piece of fruit at random. Find the probability that 2 apples are chosen. Well, there are 5 apples in the fruit basket out of a total of 16 pieces of fruit if you add them all together. And then once that apple is chosen, when Terrence reaches in, there's only 4 apples left to choose from out of 15 pieces of fruit, because remember, 1 was already taken out. So 5 times 4 is 20, and 16 times 15 is 240. Now if you simplify this fraction, I can divide by 10 first and get 2 out of 24, and then if I divide by 2, I get 1 out of 12, where the probability is 1/12. Now with that same fruit basket, if we were to try this to figure out the probability of 2 bananas, well, there are 7 bananas in the fruit basket out of 16 pieces of fruit to start. So if that's chosen, then the probability of getting another banana, there would only be 6 bananas for the second grab out of 15 pieces of fruit. 7 times 6 is 42, and 16 times 15 is 240. both of these can be divided by 2. 42 divided by 2 is 21, and 240 divided by 2 is 120. And then both of those can be divided by 3. So 21 divided by 3 is 7, and 120 divided by 3 is 40. So 7/40ths is the probability of getting 2 bananas. And then the last one, the probability of an orange, then an apple. Well, there are 4 oranges. Out of 16 pieces of fruit. Now, after an orange is selected, the probability of getting an apple, well, there's still 5 apples in the basket, but now there's only 15 pieces of fruit. So 4/16 times 5/15, that's 20 over 240, which is the same fraction we had up in this example. That simplifies to being 1/12. So the probability of getting an orange, then an apple, is 1/12.